Okay, now members, we are going to handle a new topic. This topic is dealing with indices and logarithms. So, we are going to first handle indices, then we shall cover logarithms later. Okay, what is an index? Indices is a plural word for an index. An index is a number of times a base is multiplies itself. So, the number of times a certain base multiplies itself is what we call an index. Okay, if we have a power m, a is the base, so this is the base, then this m is our index. This means that a power m means a multiplies itself m times. So if you have 2 power 3, it means that this base 2 is going to multiply itself 3 times, 2 times, 2 times, 2, 3 times, 1, 2, 3. 3 power 4, so the base is the 3, the index is 4. It's going to multiply itself all times, as you see there. Now, let us see the rules of indices that are going to help us handle these questions here. So if we have the same base multiplying, we add the powers. If you have numbers of the same base dividing, you subtract the powers. If you have a base raised to 2 powers, these powers multiply. If you have 2 bases raised to 1 power, this power is raised to this and this is raised to that, as you see there. If you have 2 numbers a over b, it means that this comes this, the same as also multiplication. Then if you have a base with a positive power, when it comes up, we change the sign of the power from n to now a negative. If it's negative, it becomes a positive. So any number, if it's in the denominator, you take it up, its power changes the sign to an opposite sign. Then a over b, if I want to get the reciprocal of this, is the same as getting b over a, then the power of this changes. That a is coming up, it's coming down, b is coming up. It's like we are applying that property. Then this is what we call the n root property. Root n is the same as 1 over n. Then if you have 2 bases, when the bases are equal, it means that their powers is also equal. Then a power 0 is the same as 1. Any number at power 0 is 1. Let us go through these ones and see. Simplify the following. 8 to the power 3 times 5 power 3. Start now. We are having numbers of the same bases. What happens? We add the powers. So this will be now a power 3. Now we add. If we are multiplying, we add the powers. So this will be now a power 8. Like that. As simple as that. What happens, okay, since it's not visible, well, this will be the same as 3 plus 5. This will give us an 8. Then if we are dividing numbers, so we are dividing x power 5, then x, you see that the bases are the same. Means we subtract the powers using this property here. We are dividing numbers of the same bases, we divide the powers. So this will be now x, the upper power, then minus the lower power. If this base is the same, this should be the same, which will be x power 2. As simple as that. Then this one, we have now more than, we first handle the numerator, then we come to the denominator. So this will be, they are having the same base. So it will be y 7 plus 4 over y power 6, which will be y power 11 over y power 6. We add this and this. And now you see that we are back on this. We are dividing numbers of the same base, so this will be the upper power minus the lower power. Like that. This will be now y power 5. And you have to do with that. When we come to this now, you start bases that look the same. What we do? We first make bases look the same. How? You look out for the smallest base. It means that you can convert all this to the smaller base. How? Look at this. You see that? How can you get this 2, you divide, you factorize 8. By 2, you get 4. By 2, you get 2. Okay, then you factorize here, and you are able to see. When I have 8 here, by 2, the small base, you get 4. By 2, you get 2. By 2, you get 1. It means that now 8 is the same as 2 power 1, 2, 3. Now, this will be now 2 power y times now. Where there is 8, I'm going to put 2 power 3, then y minus 1. Then the whole over, using most of this idea, this 16 is going to be 16 by 2. The small base, you get 8. By 2, you get 4. By 2, you get 2. Then by 2, you get 1. So that's 16. The same as 1, 2, 3, 4. 4. So 2 power 4. As simple as that. So always, you convert all the bases to a smaller base. Okay, so this will now be 2 power 4. But remember, it has the power there, this power out. Now there we come to this property, where the number is having 2 powers. These powers multiply. So there we are having 2 power y times 2. Now I'm getting 3 times y minus 1. The whole over 2 now, 4 times y minus 1. Using this property. 2 numbers, the numbers 2 powers, they multiply. So what happens there? We have now 2y, then times 2, 3y, 3 times this, then 3 times 1, we get 3. Now all over 2 power, 4 times this. Remember this is the bracket. 4 times this, 4y minus 4. Okay, now we are here. We say they are going to, if you have this and this, the powers will add in. So we have 2 now. We are multiplying numbers of the same base. We add this power to this power. So we shall be adding now 2. Okay, we shall be adding this y plus now this power with y minus 3. Remember, we are dividing by 2, 4y minus 4. Okay, what do we get there? You see that when I add this, I get 2 power, this would be 4y minus 3. So space is running out. What can I do? Okay, let me borrow this space here. So here, allow me to come this side here. Okay, so there I'll be having now 2 power now, 4y. When I add this to this, then minus 3. Then I subtract this thing down, minus, because I'm dividing, I subtract 4y minus 4. So it's when you simplify, we have now 2, 4y minus 3, minus 4y, minus to get a positive 4. So this one cancels, negative 3 plus 4y, we get 2 power 1, which will be 2. So that's how we simplify that number there, using those properties. When we come to this now, the idea is the same. This will be a power 7 times. You see that these numbers are raised to 1 power now. You see we have 2 numbers raised to 1 power here. A times b raised to 1 power. These are now this power times this power, you get a power 6 times b power 3. The whole over this times this, you get a power. Remember this power is multiplied there. 3 power 3. Then times b power 3. Now let's start this b power 3 cancels, which will give me now a power. Now we add the power 7 plus 6 over a power, this time this 9. And you know this is going to give us a power. When you add, you get 13 over a power 9. Then we shall subtract those powers. This will be now a power 13 minus 9. As simple as that, which will give us a power 4. Okay, so that's how we handle that. When you come down to these ones, they are very easy. How? You look out for this. You look out for this 1 over 3. You ask yourself, is there any number that when we power 3, we get 8? Of course, you see it here. That 2 power 3 is the same as 8. Why? The base of the power down here. So now this will be 2 power 3, the whole power are 30. But we said if a number is raised to two powers, these powers multiply. So this will be now 2 power 3 times a third. So this power cancels with this, and we shall be with a 2. Surviving. As simple as that. When you count this, you see the denominator is 4. You ask, is there a number that when we gives us a 16 when the power is 4? Yes. From here. So that's 16 is the same as 2 power 4. So now this will be 2 power 4. This is the same as this. Then 3 over 4. Now instead of the number, we are going to multiply the powers. So 2, 4 and 3 over 4. This number is having 2 powers. So this cancels with this. This will be giving me 2 power 3. And 2 power 3 is 8. As simple as that. We have simplified that into indices. When you come down to this one is saying, if we have a negative power, we want always a positive power first. So what happens if we have a negative power? You get a reciprocal. If you get a reciprocal, now the power becomes a positive. So now, if we get a reciprocal of this goes up, then this comes down. Now, after doing that, now this power is going to become a positive. When you get a reciprocal, the power now becomes a positive. As simple as that. Now, remember, now with this property, we have two numbers with one power. Means that this power comes to this and this power comes to that. Okay, now you look at this. 16 is there. Okay, 16 is going to be, is there any messing with this power? I'll be having now 16 power half over 25 power half when I use this property here. Now, is there any number when my power is the denominator is power is 2? Is there a number when I put it to power 2, I get 16? Yes. That number is 4, power 2, power half. Then the same here. I see this is a 2, so I mean I should express this as a sum number with power 2. That number is 5. So when I get 5 squared, I get 25. When I get 4 squared, I get 16 power half. Then they multiply. So 4 power 2 times half over 5 power 2 times half. This and this they cancel. This and this they cancel. And this is the only thing surviving is 4 over 5. That becomes our answer. You also see this that it's also the power is negative. You first get the reciprocal. Now the reciprocal will be this goes up, then this comes down. When you get the reciprocal, now this power becomes a positive 2 over 3. Now you separate this power to this also to the denominator. So this will be 27 2 over 3 over 8 2 over 3. Now you see the denominator is 3. But this denominator is giving you what power do you need? Is there any number with power 3 and you get 27? Yeah, you come and you factorize. You have 27. You see by 3, 9. By 3, 3. By 3, 1. So now 27 to the same as 3 power 1, 2, 3. 3 power 3. As simple as that. So this will be 3 power 3 now times. Remember we have 2 powers. Over, this is going to be 2 power 3 times 2 over 3. Because 8, we have seen already 8 is the same as 2 power 3. So this and this they cancel. So you have now 3 power 2 over this and this cancel over 2 power 2, which will be 9 over 4. And we have simplified that. So that's how we handle those numbers. I wish you well.